Hello, welcome to episode 3 of this playlist where we are talking about asynchronous programming in JavaScript. In this episode, I'm going to talk about callback hell, which is the issue that, callbacks cause. So in episode 2 and episode 1, we talked about callbacks. So passing one function as a parameter to another one, right? So this is the simplest way of achieving asynchronous programming, but I told you this causes many problems, and in this episode I'm going to show you this problem callback hell, or sometimes it is called the pyramid of doom. And then from episode 4, where we start talking about promises, you will better understand the importance of promises, and you will appreciate the way that promises make coding easier, asynchronous coding easier. So the objectives of this episode, we're going to talk about callback hell, as I told you, why it is problematic. We're going to perform multiple chained asynchronous operations. So the problem of callback hell, or the pyramid do, starts to appear when you want to chain multiple asynchronous operations together. So for example, you want to create a task, our backend API, right? And after the creation is complete, you want to call another callback, which is going to update a task. And after that update is complete, you're going to, call yet another callback to delete a task. So when you chain multiple asynchronous operations together, that problem, callback hell, will start to appear. So we're going to identify the difficulty in maintaining and debugging nested callbacks, and we're going to prepare for a smoother solution using promises in the next episode. So let's talk about callback hell. So callback hell, sometimes known as the pyramid of doom, happens, as I told you, when callbacks are nested within other callbacks. So when you're chaining multiple asynchronous operations together. So this makes your code highly indented. So it creates multiple levels of indentation. It increases the cyclomatic complexity of your code, and it makes your code hard to maintain, hard to read. It is not good. So this makes debugging, testing, and maintaining code very difficult. We're going to simulate this scenario. So we have 3 asynchronous operations: adding a task, updating a task, deleting a task. We're going to chain them together, and we're going to do that using callbacks, and you will see how using callbacks is going to cause problems. So this is the callback hell problem in action. We've got, as you can see, this function, right, create task, which is going to receive a task to create and a callback, and the callback is going to be invoked here. So you're already familiar with this code. We saw this, right, in the I think episode number 2. So this is the first asynchronous operation, create task, receiving a task, receiving a callback, and if, for example, the operation is successfully completed, use that callback, right, to invoke another function with these 2 parameters, and if it is not successful, use the same callback to invoke the function with these parameters. The same thing happens for the next asynchronous operation. So update task, it is receiving a task and a callback, right? And again, if, for example, the operation of updating a task is complete, you can call your callback using this. Otherwise, you're going to invoke it using these parameters. The next one is delete task. Again, we're receiving a task ID to delete as well as a callback, and then based on whether the operation of deleting a task is successful or not, we're going to call the callback with these 2 sets of parameters. And this is where the problem of callback appears. So take a look at this. We have this function which is called create task, and as you can see, it is receiving this task with a title and a value for completed flag, and then we have this callback as well, so error and new task. And then we are going to chain those 3 asynchronous functions together. So first off, as you can see here, we are calling the create task, which is the first asynchronous function. Then inside of it, we are calling the update task, and then if that's successful, we are calling the delete task. So the three asynchronous operations are chained together. And we know that these asynchronous operations, as the first parameter, they will receive a task object, right? And as the second parameter, they're going to receive, a callback. So this is the callback that these, asynchronous functions receive. And these are the first parameter. For example, for delete task, we receive the ID of a task. For update, we receive a task. For create, we receive a task. If you take a look at the code, you will understand that we are, creating levels of indentation. So this makes your code harder to maintain. As the number of asynchronous tasks that you are chaining together increases, the code becomes more complex, more difficult to maintain. So I'm going to take you to VS Code now and implement this inside of another code file for this episode. So this is, my VS Code instance. I'm going to create a branch for episode 3, and I'm going to create a new file called episode 3.js. I'm going to reference the file here, and I'm going to navigate to, this episode 3 and start writing the code. So let's first create our 3 asynchronous functions for creating a task, using XML HTTP request, for deleting a task, and for updating a task. You're already familiar with this code. If it is a little bit unfamiliar, you just need to watch episode number 2, because in episode number 2 we talked about this piece of code. We also said that it is possible to use Axios or Fetch API, which we will use in future episodes, but in this episode we're going to use the XML HTTP request object. So this is the first function. The next one is update task. So again, for create and for update, we will receive a task as well as a function. For delete, we will receive a task ID as well as a callback. So let's write the code for update task. Let's call the callback if the operation is successful, and if it is not successful, let's call the callback with a new set of parameters. Now, the last asynchronous operation is going to be delete task, which receives the task ID and a callback. So this is the, code for invoking the callback if deletion is successful or unsuccessful. And then we're going to chain these together. First, let's call the first function, create task. Create the task, passing the flag, and now the callback, which takes an error and new task. And then we're going to update the task using the same signature of update task asynchronous function. And finally, let's delete the task. So we're done. We're done with this code now. Now all I need to do to test this is to open my console. There is an error. It says failed to create task. Let me refresh this. Yes, I ran my API on my machine, so my API was not running. So as you can see, the task has been created, then the task has been updated, and then finally the task has been deleted. 3 asynchronous operations chained together. But as you can see, this section, right, you can already see that we are creating multiple levels of indentation inside of our code. So these levels of indentation make the code more difficult to maintain and more difficult to understand. And this is something we need to avoid. Right now we have 3 asynchronous operations, but chances are we will have to, chain more than 3 asynchronous operations together, which means that the level of indentation in our code will increase. And the reason is, for each asynchronous operation, we are going to have a callback, right? And then inside of the, the first, asynchronous operation, we're going to call another asynchronous operation with its own callback. And this goes on, and this will create, as I told you, multiple levels of indentation. This is called callback hell, or the pyramid of doom. So each function handles one asynchronous task with callbacks. The callbacks are nested, and each one depends on the result of the previous one, and this leads to deep indentation and difficulty handling errors or logic at each step. And when you run the code, you will see these 3 messages. So this is one very important thing you need to remember about using callbacks when you want to write asynchronous code. Even though they're simple to understand and they're used, they pose a very serious threat to the maintainability of your code. They make the code difficult to understand and difficult to maintain. The code becomes hard to read because of those indentation levels. You cannot manage errors, effectively. And as the number of asynchronous operations grows, the code will become even more, unmaintainable. And of course, the code becomes difficult to reuse as well. But the good news is that all of these issues and many more can be resolved using promises, which is a more, effective way to handle asynchronous operations and the result that those asynchronous operations return. We will start talking about promises in episode number 4, and we're going to see examples of promises and the powerful nature of using promises to carry out asynchronous operations. So if you enjoyed watching this video, make sure you stay tuned and continue watching the next videos as well. Bye-bye.